All right. So I'm going to go through and I'm going to just work through these problems. If at any point in time you have a question, please just stop me. I will show kind of a variety of ways that I would answer some of these questions, and then I'm just going to try and do it the most straightforward way. That way you can come back to this, review it on your own, and then you can see what I or how I did it. And then, like I said, if you have any questions, just stop me and ask away. So the first thing we are going to encounter on our test is going to be the some basic conversions. As a reminder, when you're going from metric to metric, like milligrams to grams, micrograms to milligrams, you do not round those answers. Okay, so you leave them as they are. You will round when you go from pounds to kilograms, pints to milliliters, ounces to milliliters. You know, you may not need to round, but if you are going between two different units, then expect to round. But if you're staying within the same system, metric system, then don't round those numbers. All right, so there's a couple ways to answer this. So 1500 milligrams to grams. If for keeping it simple, you have a decimal point that's right here. And what I'm going to do is I'm just going to move it over 1, 2, 3 places. And my answer is 1.5 grams. Now you might be saying, well, I don't know which way to move it. And sometimes I think I'm going the wrong way. Just remember 1 gram is 1000 milligrams. So if you get that, then you at least know that 1000 milligrams is 1 gram. So 1.5 milligrams will be, or sorry, 1500 milligrams would be 1.5 grams. But if you ever get stuck, you can also do dimensional analysis. Okay, so 1500 milligrams over 1. Remember, you don't want milligrams, you want grams, and 1 gram has 1000 milligrams. So if you ever get stuck, or if you ever feel like you're going the wrong way with your moving your decimal over, write it out. Okay. And then again, I like dimensional analysis because you can cross out your units and you know that you are going to end with what you're looking for. And then you would just plug that into your calculator and you get the same thing. Now we'll say, like, let's say this number was 1275, then your answer would be 1.275 grams. That would be your answer. Do not round the 1.275 to 1.3. Just leave it as it is. So it can have, it's probably not going to have more than 4 digits. But just as a reminder, don't round your basic unit conversions. Micrograms to milligrams, I'm going to do the same thing. I know that there's 1000 micrograms in 1 milligram. And so that tells me I'm going to move my decimal point over 3 to the left again. And so my answer would be 0.25 milligrams. Again, I would set that up exactly the same way as I did up here. 250 micrograms over 1 times my conversion factor. So I know I'm trying to get rid of micrograms and I want milligrams. 1 milligram is 1000 micrograms. And so I get the 0.25 milligrams. I don't really need to show too much work as far as this is concerned. You just need to know to divide this number by 2.2. So when we're going from pounds to kilograms, and usually that's what you're going to be doing, is going from pounds to kilograms, you just need to know to divide the pounds by 2.2. So on my calculator, so much for having that open here, 165 divided by 2.2 will give me an even 75 kilograms. So that's my answer. I don't need to worry about rounding. For 117 though, divided by 2.2, I'm going to get 53.18181818. It's a repeating number, and that's your clue that you need to go ahead and round. And so 53.18 would round to 53.2 kilograms. Pints, we need to know that 1 pint is equal to 2 cups. 1 cup is equal to 240 milliliters. And so you could say that 1 pint would then be equal to 2 cups, which is 480 milliliters. But if it says 1.5 pints, we can convert pints to cups, or if we recall that, like as I just said, that 1 pint is 480 milliliters, then we can just go ahead and use that as our conversion factor. And so what I'm going to do is I'm going to take my 1.5 pints and I'm going to multiply by the conversion factor we just discussed, because I can go directly from milliliters to pints. Well, we know that 1 pint is equal to 480 milliliters. Okay. So 480 times 1.5 will give you 720 milliliters. Which is the same thing as 3 cups, right? So 240 plus 240 is 480, plus another 240 is 720. Just a couple different ways to answer that. Ounces to milliliters. 1 ounce is equal to 30 milliliters. So I'm just going to multiply this number by 30. I don't really need to show anything. And then my answer for that is 120 milliliters. Yeah, I'm sorry, I wrote this here, but it was already written. It's okay. Half a cup, where he talked about a cup, 1 cup is 240 milliliters. So 240 divided by 2 will give you the same answer, 120 milliliters. Okay, so that's how you would do those, what they call the basic unit conversions. If it's metric to metric, don't round. And then if it's metric to imperial or household, or household imperial to metric, then you're going to make sure you round if you need to. Usually when you're going like pints, ounces, cups to milliliters, you're multiplying by a whole number. So you are most likely not going to need to round. But when you go from pounds to kilograms, more often than not, you're going to need to round to the nearest tenth. All right. Fluid intake. So the first fluid intake says that we're going to calculate how much total fluid intake in milliliters for the meal listed below. And then we're going to assume that if something is listed as a glass, it's 8 ounces. Okay. So this says a quarter glass of orange juice. I doubt you're going to see quarter and 3/4 and 2/3, but I figured if I create a practice where you have to think through it, it makes you, or forces you to kind of work the math. And then that way you're not making a mistake. So anytime you see 1/4 and you know that it's 8 ounces, all you're going to do is you're going to take 1/4 times the 8 ounces. So that's 8 over 1, which is the same thing as 2 ounces. Okay. Alternatively, you could just say, 8 divided by 4, which again is 2, or you can say, okay, well, half of 8 ounces is 4 ounces, and then half of that would be 2 ounces. So there's a couple different ways you can kind of do that. And then we know that 1 ounce is 30 milliliters. And so I can even just put that over 1 ounce if that makes, sometimes when I do these things, I skip some steps. Okay. But 2 times 30 would just give you 60 milliliters. 6 ounces of coffee. Again, we're just going to multiply by the 30 milliliters to give us 180 milliliters of coffee, because 6 times 30 is 180. Reuben sandwich, right? That's not liquid. 2.5 ounces. So again, I'm just multiplying by the 30 milliliters. So 2.5, 2.5 times 30 is 75 milliliters. And then as we discussed above with a pint is 1 pint is 2 cups. So a half pint is 1 cup, which means it's 8 ounces times 30 will give me 240 milliliters. Okay. Or you may have already just known that it was 240. You don't necessarily have to write all that up. then I'm going to just add up all my numbers, right? So 240 plus 75 plus 180 plus 60 will give me a total volume of 555 milliliters.
So for the half pint, a pint is 480, right?
Yes.
So then you could just divide by 2. That's how
Perfect.
I got 240. Okay.
Yep. That's what I'm if you ever forget what a pint is, then and you can relate it back to cups, that's just kind of where I go. But you're exactly right. I even mentioned that. So 1 pint is 480 milliliters. So half of that is 240. You got it. All right. For this, so we got chicken broth, Jello, some tea, and some water. So again, for anything that's marked in ounces, multiply by 30. Multiply by 30. Multiply by 30. And then here for 2/3 cup. So you might say like, well, what's the point of this? And, just trying to be fancy, I guess. But you're going to take, I'm just going to tell you, like, if you can do 2/3 times a cup or 2/3 times 8 ounces, or because you already know that it's 1 cup is 240 milliliters, just 2/3 times 240. And then you can save some steps doing it that way, because 2 times 240 divided by 3 gives you 160 milliliters. So again, you can go ahead.
Go over that? Can you go over that again?
Sure. So we know what 1 cup is 240 milliliters, right? So I just did 2/3 times 240 milliliters.
Wait, so 2 divided by, you just did 2 times 40 or
2 times 240,
2 times?
right?
Oh,
Because
okay.
one cup is 240 milliliters. And then so 2 times 240 is 480 divided by 3 is 160.
Okay. Thank you.
And like I said, I doubt you're going to see 2/3. You might see half. Okay. I just put that on there just to, make it more challenging. Then I'm just going to add these up. 160 plus 240 plus 60 plus 180 gives me 640. Okay. All right, next set. So for here, for lactulose, 45 grams by mouth TID, and it says it's available as an oral solution, 10 grams per 15 milliliters. So for our order, we have 45 grams. For our available, we have 10 grams per 15 milliliters. And then the question goes on, it says, how much medication will the patient receive in 1 dose? So it's an oral dose. When we have an oral dose, it's either going to be a tablet, a capsule, or it's going to be milliliters. Okay. And so the clue here is, if you ever not know, or it's not listed here, just know that if it's an oral solution, it's going to either be, if it's an oral solution, it's going to be milliliters. But if you're not sure it's an oral solution, then you would see and look for something indicating that it's milliliters, or otherwise it would just say per tablet or per capsule. And so following and doing what's called order over have, I would take my order over my available times my quantity, 45 times 15 divided by 10 gives me an answer of 67.5 milliliters. So that would be my answer.
So you wouldn't have to convert anything if it's.
Yeah, there's nothing to convert here. I mean, technically we're converting grams to milliliters, but right, we're not converting anything because they're both in grams.
Okay.
If one of these were in milligrams and the other in grams, then yes, you would need to convert. And there might be an example of that on here. We'll see. Can't remember. All right. This is for Xanax. Our order, as we can see, is the 0.75 milligrams by mouth BID. It tells us we have available 0.25 milligrams, and it's in the form of tablets. And so this one is as straightforward as taking the order over the available times the quantity, which is the one tablet, and it's 3 tablets. So we know it's not a liquid because it doesn't say anything about an oral suspension, and it clearly says on the label tablets. Okay. Zofran. Order is 10 milligrams by mouth 3 times a day. Available as Zofran. It's in a 100 milliliter bottle, which is important because we want to make sure we have enough quantity. But what we care about is this right here, the strength, 4 milligrams per teaspoon. And then this specifically tells you how many milliliters will the patient receive in one dose. So one of the things is, since we're going into, and we know that we're looking for milliliters from the get-go, just go ahead and convert, because you should already know that 1 teaspoon is the same thing as 5 milliliters. And so I would rewrite this available as 4 milligrams per 5 ml. It's the same thing. Teaspoon is just obviously a simpler version of that, but because it just says 1, or you don't even have to put a number there, but we know that it's the same, they're equivalents. So once you know that, then you can take your order of 10 milligrams over your available 4 milligrams times your quantity, which is now 5 milliliters. So you don't have to worry about converting teaspoons to milliliters because you already did that step. 10 times 5 divided by 40 or 4. And you're going to get an answer of 12.5 milliliters. Don't forget to write your units. Okay. All right. For Benadryl or diphenhydramine, it says the order is 65 milligrams intramuscular. As soon as you see extra intramuscular, you know it's milliliters. We don't have any other way of injecting a liquid that's not in milliliters other than maybe cc's, but intramuscular is milliliters. Okay. And then I'll show you the other way to know that you're dealing with milliliters in just a second. Every 6 hours as needed for itching, not or itching, but for itching. So it says the available is 50 milligrams per milliliter. So that's the other thing. This looks just like a solution, and you probably know or have even seen or used Benadryl as an oral, like it comes in tablets, it comes in capsules, it comes in injectables. Now we're seeing, and then it also comes in like an oral suspension. So it comes in a variety of different applications. This one is just specific for an intramuscular injection. So we know it's milliliters. This is the other clue, is that it says milliliters in the strength or the concentration. So I'm going to take my order of 65 milligrams. I'm going to divide by my available 50 milligrams times my quantity, which is 1 milliliter. 65 divided by 50 is 1.3 milliliters. So that would be your answer, 1.3 milliliters. And then you would shade the dose. So I'm at 1, 1.1, 1.2, 1.3. So I would just shade my dose appropriately to make sure I cover all that in. All right. Heparin. The difference between heparin and some of these other things that we've been looking at is instead of saying milligrams, or it'll say units. Okay, so the unit of measurement for heparin and for insulin is units. So the order is 7,000 units. You have heparin 10,000 units per milliliter. Now, I will say, if you go and you're looking at this and you look at these labels and you immediately go like, how does he know where to look for it, like without looking around or even do it? I've been doing this for years, and honestly, it just comes from practice. And then I'm trying to role model what you should be doing when you're going through this initially, just for practice, is circling the important information, underline the important information, because it's a good practice, just in case you ever get stuck. Okay. So my order, 7,000 units. My available is the 10,000 units. And then my quantity is 1 milliliter. My little trick here for anytime you have numbers with lots of zeros, and you're worried maybe about plugging it into your calculator incorrectly. Now, of course, you can just put in 7,000 over 10,000, not a problem. But what I do is I look at the number of zeros in 7,000, 3, the number of zeros in 10,000, 4. And what I do is I eliminate the least number of zeros. So I can only eliminate a max of 3. And so I take away 3 here, take away 3 here, 7 over 10. I'm not going to make a mistake plugging that in my calculator. At least I'm less likely to. And so my answer would be 0.7 milliliters. And then just like the previous question, I'm going to mark the syringe. So here's 0.5, 0.6, 0.7. And it says to shade it in. So I'm going to shade it in, and you'll do a much better job. And if this is a Blackboard test, obviously you probably won't be doing any shading, but if it's a paper test, shade away. All right, here's one where we don't have to worry about doing any kind of math. We just need to follow directions. So this is a sliding scale, an insulin sliding scale question. So it tells you that the client's blood sugar at noon was 315. How much insulin should you administer? You're going to look at your sliding scale. You're going to see the range of 301 to 350. And so you're going to administer 8 units. And the reason you don't need to worry about converting units to milliliters is you're going to see in the syringe is also listed in units. I know that doesn't look clear enough to say that is units, but that's what it is. So I'm going to go to 5, 6, 7, 8 units. Shade the dose. And that's how much insulin they're going to receive. 8 units. All right, now this one is just combining 2 insulins. If you're ever asked, remember you're going to draw up regular insulin first, and then you would draw up the NPH second. But this question just asks, you're going to add the 2 together, so 14 and 18. So 14 units and 18 units, which gives you a total of 32 units. And then you're just going to mark it on the syringe. 30, 31, 32. And then just shade in the syringe, indicating 32 units. All right, Synthroid. So this question usually gets missed sometimes just because if you haven't looked at these labels before, sometimes there's information on here that seems like it's confusing, and I'm going to help clarify it. So first of all, we look at our order, 0.25 milligrams by mouth daily. Then we're going to look at our label. We know it comes in tablets, so we know that we're giving and administering tablets. And then it says 50 micrograms. So that is the dose per tablet. But then it also says 0.05 milligrams. Okay. So these are the same dose or the same strength, right? Because 50 micrograms equals 0.05 milligrams. And if you are ever concerned about that, just take 50 divided by 1,000, and you'll see that it's the 0.05. It's the same number. So what number then would you use when you're doing your dosage calculation math? Well, if your answer is in milligram, or your order is in milligrams, use the milligram dosage. If your order was in micrograms, use the microgram dosage. So you don't need to convert anything. You don't need to multiply these two together. Just know that they're indicating the same strength, just in different units. So setting this up, 0.25 milligrams over the 0.05 milligrams times the 1 tablet. So 0.25 divided by 0.05 gives you an answer of 5 tablets. So how many tablets would they receive in a dose? They're going to receive 5 tablets. All right. So the label already jumps out at you and says Prozac, and it says it's a liquid. So you know that you're looking for milliliters. So I always try and use the clues that the question gives. Okay. So what's my order? 65 milligrams. And then what do I have available? 20 milligrams per 5 ml. Okay. Again, I go through and I'm looking at the label, and the strength is typically highlighted right, bold, and it's usually easy to find. There's clear around it. It's not, you don't have to find it through all this writing. You'll see that in a moment when we get to the reconstitution problems. But anyways, so I'm going to take my order, and I'm going to take my available, and my quantity in this instance is 5 milliliters. So I'm going to take my 65 milligrams times 5, which gives me 325, divided by 20, which gives me 16.25. And then when I have a number like this, if I don't have the syringe that can go down to the hundredths place, or if it doesn't even ask you to do anything with a syringe, you are going to go ahead and round that number. You're going to round it to the nearest tenth. So your final answer would be the 16.3 milliliters, because 5 would cause it to round up. So see, there's no syringe associated with this question. So that's your clue then to round to the nearest tenth, because the number is greater than 1. And for numbers greater than 1, we round to the nearest tenth. The exclusion being when we're doing basic unit conversions, metric to metric. Oh yeah, I'm sitting there looking for syringe, and this is an oral dose. So that's obviously there are oral syringes, but that's not what we're talking about here. So anyways, all right. Dilantin available, or order 175 milligrams. It's going to go into via nasogastric tube. So in your nose, it's not going to be powder. It's going to be liquid. And then it looks like they're using an oral suspension in order to achieve this. But you can see that my strength is 125 milligrams per 5 ml. So now you know that your answer is going to be in milliliters. Okay. And then I'm going to take my order divided by my available times my quantity. Again, this is 5 milliliters this time. 175 times 5 gives you 875 divided by 125 gives you a nice even 7 milliliters. All right. Potassium chloride. Every time I see this question, students usually get hung up on this thing right here, milliequivalents. Milliequivalents just tells you that that's the unit of measurement that potassium chloride is available in. So it's no different than milligrams. It's no different than micrograms. It is no different than units like we saw in insulin and heparin. It's just that's the unit of measurement. What I care about is, can I convert milliequivalents to the quantity that I need for a dosage? And so how do I know? This is by mouth, but how do I know? Is it a liquid? Is it a powder? So we look at our label, tells you potassium chloride oral solution. So solution means that it's going to be something per milliliter. And here's my 20 milliequivalents per 15 milliliters. When I see this, I don't know, you probably think the same way. It kind of looks like, half and half that you get at like the restaurant. It's like those little like half and half packets. It's kind of what this looks like. So almost looks like there's that, or like a yogurt lid, however you want to look at that. To me, it looks like a half and half. So our order is 75 milliequivalents. My available is 20 milliequivalents for every 15 ml. Okay. So 75 times 15 gives me 1,125 divided by 20 gives me 56.25. And so I'm going to do the same thing. I'm going to round it to the nearest tenth. So 56.3 milliliters. All right. Here's another one. So penicillin is another one that kind of gets measured in units. Your available is the 1,000 units for every 10 mil, or sorry, 1 million units for every 10 milliliters. So you're going to take your 250,000 units, your order, or over 1 million. This is units, and then times the 10 milliliters. Now, I'm going to follow the same rule I mentioned before. So 250,000 units has 4 zeros. 1 million has 6 zeros. So I'm going to take away 4 here. I'm going to take away 4 here. 25 over 100 is much more manageable. So I'm going to take 25 times 10 divided by 100. And I'm going to get an answer of 2.5 milliliters. Now, the thing that's interesting about this question is I didn't indicate like, is it an injectable? Is it an oral solution? Didn't say anything like that. But by process elimination, and anytime they give you that milliliters in the concentration, that's your clue that you're dealing with. A milliliter will be what your dose will be administered in. And then I think this is an injectable. All right. Here we have a syringe, so that's a good indication that we're dealing with an injectable, right? It also tells you milliliters. Okay. So it says the meperidine hydrochloride, 45 milligrams intramuscular. Again, that tells you milliliters. Every 4 hours is needed for pain. It's available at 75 milligrams per milliliter. What's the what's the dose? So I'm going to take my 45 divided by 75 times my quantity. So 45 divided by 75 gives me an answer or quantity of 0.6 milliliters. So here's 0.5, here's 0.6. I'm going to shade the dose. There we go. All right. Another another injectable, and we can see that clearly on the label. It says injection here. It says clindamycin, 0.45 grams, intramuscular. That's the other clue that it's going to be, or you're going to calculate milliliters from this. And then it says, so it says 0.45 grams. And then what's my order? It says 600 milligrams, 4 ml, but right underneath it, it gives you 150 milligrams per milliliter. So if you want to double check, 600 divided by 4 is 150. So you can use either strength. They're both the same number. It's just the 600 over 4 gets reduced to 150 milligrams over 1 ml, just so you know. So the whole, if you gave them the full injection, the full 4 milliliters, because you see a single dose vial is 4 milliliters. If you gave them the whole 4 milliliters, they're going to get 600 milligrams of this antibiotic. Okay. But here it's telling you it wants 0.45 grams. Okay. And your availables in milligrams. So we need to convert 4.45 grams to milligrams. So you can do that one of two ways. I can move this over 3 places, 1, 2, 3. And so that equals 450 milligrams. And if you are not 100% confident on that, remember 0.45 grams. And my conversion factor for grams to milligrams is 1 gram is 1,000 milligrams. And that will also equal the 450 milligrams. Once I have the 450 milligrams, now I can do my order over my available times my quantity. 450 divided by 150 is 3 milliliters.
So you could basically do that either way, like 450 divided by 150, or you could do like 450 times 4 divided by 600 and you'd get the same answer.
Let's do it. Let's just double check. So 450 milligrams over 600 milligrams times 4 milliliters. Let's see if we get the same thing. So 450 times 4 divided by 600. Same thing. So the long answer is yeah, or the short answer is yes. And then I wanted to show you that either way, the only way you would mess this up, I mean, obviously there's lots of ways to mess up all these problems, but if you decided to do 150 milligrams, 4 milliliters, then you're using the wrong concentration. So whichever one you choose, just make sure you're using the same numbers. I chose the 150 because I always like to use the lowest number, but that's just a personal preference. And sometimes they don't even give you both options.
So if you didn't want it to do like the long way, you could just divide by 150. Like
you got it.
Okay.
You got it. Yep. So yeah, you're gonna give them 3 milliliters, and you're basically going to use the whole syringe. You probably need a bigger syringe for this question, but that was just the example here. There's always the concern that the sample won't work for what we need it for. Okay. All right. 2 more questions. I think these are both the reconstitution. So we're dealing with a syringe. The order of Kefzol, 325 milligrams. Intramuscular tells you right off the bat, milliliters is what you're going to be doing or calculating for. And a couple clues to know that you're dealing with a reconstitution problem. When it says grams, and it doesn't say anything about milliliters, but you know that it's an injectable, that's a good clue that it's a reconstitution question. And when you know that it's a reconstitution question, then that tells you you need to go into the side label. Okay. So it tells us for intramuscular use, you're going to add 2.5 milliliters to the injection, shake it up for an approximate volume of 3 milliliters. And then the thing that we're looking for is the concentration. Concentration is 330 milligrams per milliliter. Oh, give me 1 second. I just want to check something real quick. Sometimes, like if this wasn't given to you, the 330 milligrams per milliliter, if you took the 1 gram, which would be 1,000 milligrams, you divide that by the 3 milliliters, you get 333.333333. That would be milligrams per milliliter. So this is an estimate of that concentration. There are some examples of reconstitution where they just tell you the total volume, and they don't tell you anything else. That's why I'm saying it now. And all I said was you would convert grams to milligrams divided by the total volume in order to get your strength. Okay. But if it's given to you on the label, this is what you use. So my order is the 325 milligrams. My available is the 330 milligrams. And my quantity is the 1 milliliter. 325 divided by 330 gives me 0.9848484848. So a number less than 1, you would round it to the nearest 100th place. And let me just write my milliliter up here so I'm consistent. So my answer here for this one would be 0.98 milliliters. But when it says to mark it on the syringe, I cannot mark 0.98 milliliters on the syringe. So if I were, first of all, I don't think that you would get a question that would end in an answer like this. You're going to get like, it would be 0.9 or it would be 1.2. It's going to be more concise. This was just a sample and I just made up the number. If I were writing up a test, I would make sure that it ended on something that you could shade easily. But if it comes down to it, 0.98, we're essentially talking about 1 milliliter. You can't estimate on your syringe. You have to mark it to exactly where it is. But if it were me and this was the best I could do, then I would go ahead and round it all the way up to the 1 milliliter mark. Okay. But I don't think you're going to see something like that on your test. I'm just mentioning that just because we're working with what we have here. All right. And the last question is another reconstitution question. It tells me 250 milligrams is my order. Intramuscular tells me milliliters. And the reason I knew it was reconstitution is because it tells me I have 500 milligrams. It doesn't say anything about milliliters, but I know I need to know milliliters in order to do my calculation. Okay. So that is your clue to go into the label. Okay. And then look for the what happens after sterile water is added and what kind of concentration we get. So it tells us the usual dosage range. So we're within that range. It says for intramuscular administration, you're going to add 2 milliliters of sterile water, shake well, and then it provides an approximate volume of 2.2 milliliters. And then this is what we're looking for right here is the strength is 225 milligrams per milliliter. Now, the other thing I can take is if I take that 500 milligrams divided by the 2.2 milliliters, 2.2 milliliters, I actually get a concentration of 227 milligrams per milliliter. So again, you're always going to use what the label tells you. But if the label doesn't tell you and you ever get stuck, then you would just take your total medication divided by the approximate volume. And that would be how you would calculate or estimate the strength. But every example that I have seen, they give you the label and it gives you that information on the label. So you don't have to guess. You don't have to do that extra legwork to do it. I'm just giving you a way in case you ever encounter something like on ATI or NCLEX, at least you have something that you can try to get to an answer. So my order is the 250 milligrams over the 225 milligrams available times my quantity of 1 milliliter. 250 divided by 225 gives me an answer of 1.111111. So my answer would just be 1.1 milliliters. And then I believe there's a syringe to this. So yeah, 1.1. Hold on 1 second. And then I would mark the syringe 1.1. And then there we go. So go ahead. What's your question?
I have a question. If the same unit like mg to mg, you need only to divide or what?
Say that one more time.
If the same unit, you need only to divide, like for example, 250 mg over 125 mg, you need only to divide for that, right?
I'm sorry, I'm having a hard time hearing you. Let me just see if my microphone's working or my speakers are working properly.
I hear you well. I think my headphone is have a problem. My question is, you need only to divide it the same unit, like this one, 250 mg over, let's say 125 mg. You need only to divide that one, right?
Yeah, but you need to be in the habit of multiplying by the quantity because that quantity can change depending on the different concentrations that you may encounter. So if this said 225 milligrams per 5 ml, you would need to make sure you multiply by 5. But when you're plugging into your calculator, yeah, you for this particular problem, 250 divided by 225 is all you're doing.
Okay.
So I just went through all 25 questions with kind of slowly going through each of them. And you could see that we did that in under an hour, which is good. And then as I mentioned to you last time, I'm just going to go ahead and stop the recording here for a second.